Okay, it should be.
Yeah, it's on.
Okay, good.
Yeah.
All right. Okay.
Okay, good morning. Welcome to MCMC Summer excuse me, MCMC Summer 2016 webinar series. This presentation is titled Zscaler Tips, No Tricks. Your presenters for today will be Diane Dunlap and myself, Gans Guzman. After this presentation is over, the slide deck and the recorded presentation will be available at the link below, and this link will appear again on the last slide, so you don't have to go ahead and capture that now. Okay, so today's agenda for this presentation is going to be, we're going to look at some features within Zscaler that probably may be new to you, that would be useful, some common configuration mistakes. We're going to look at some known Zscaler issues. We're also going to look at how to get data out of the logs. Okay, so as I said, we're going to look at some features that you may have missed that have been added to Zscaler within the last few releases. So we'll go ahead and take a look at those. Okay, so the first feature we're going to look at, this one, some of you have actually started using it, some of you haven't. It's the ability to be able to restrict the Google domain access. I know that this feature currently exists in the Google admin UI. The differences between this one and what you see in the Google admin UI is how it's applied, right? So when you create this, when you enable this function within the Google admin UI, this restriction gets pushed down to your users who authenticate against your domain, right? So they actually have to be associated with your domain. They authenticate against your domain. The policy gets pushed down and they get restricted to your Google Apps domain, right? But if that user doesn't log into your Google Apps domain, this policy does not get pushed down and it does not apply to the user. Also, this policy only applies to Chrome. While with the Zscaler feature, this applies to all the browsers. And doesn't matter whether or not the user is authenticated against your domain or not. If that traffic hits Zscaler and you're using this function, it will apply to that user. So the good and the bad, right? This is a global policy, so it's going to apply to all your users, whether it be a guest, a student, or staff, right? So this is a more restrictive policy, I guess, than what you would configure within the Google Apps management domain. But if this is a requirement, this is a way to achieve it. And this particular function is found under policies, URL, and cloud application controls, and then under advanced settings. Next slide. So when you do apply this feature, this is what your users are going to see. This is the error message they're going to get in the browser. This error message is the same whether you configure this in Zscaler or you configure this in the Google Apps domain. So just be aware of that. This is not specific to just a feature within Zscaler. Okay, so the next function we're going to look at is the ability to do SSL inspection bypasses for applications. Before, you would basically create a custom category. You would put in the URLs that you want to do an SSL bypass that were pertaining to, let's say, Facebook, Pinterest, Twitter, whatever the case may be. And then you would apply an SSL bypass against that custom category, or just manually type in the URLs there for the URL bypass. So this gives you the ability to do it by application so that you don't have to know what all those URLs are that are associated with that application. Like in the case of like Facebook, I believe there's like 4 or 5 URLs that are associated with just that application. So it's more than just www.facebook.com. I believe it's also www.facebook.net, fbknc dot something. So like I said, this is just a way of bypassing applications for SSL inspection without having to know what all those URLs are and not having to create a custom category for it as well. This particular function is found under policies and then SSL inspection. And then when you look at the SSL inspection policy, you'll see this in there. Next. So the next one that we're going to take a look at is going to be under the advanced settings. This particular one is for the authentication bypass, right? If you're going to create an SSL bypass, you may also need to create a corresponding authentication bypass. You may or may not, right? Just know that if you bypass an application from SSL inspection, you cannot allow that application based on a user or a group of users, right? Because you just bypassed authentication for that application. right? So just be aware of that, right? If you do use this function, that's a kind of a caveat. Make sure that you're not allowing access to that application by username or a group of users. Next slide. Okay, so this is one that I sort of scratched my head on because after thinking about it for a while, I kind of understand why Zscaler did it, but when you actually look at it at face value, they basically broke your reason for creating a custom category. So let me explain. When you create a custom category, you are essentially taking a URL or a group of URLs and you're putting it into a category that you defined yourself. And by doing that, you effectively rip that URL out of the Zscaler parent category. The reason why you do this is because usually you're trying to allow a very small subset of a category. So let's take social networking, for example, right? Let's say you want to allow Pinterest. Pinterest is categorized as social networking. So you would add Pinterest to a custom category, which essentially would rip it out of the social networking category, so you wouldn't have to allow that entire category. You would just allow that custom category, which just allow Pinterest and not Facebook and Twitter and whatever else may be categorized as social networking. But with this function here, if you add, so let's say you create a custom category, you call it Pinterest. You add .pinterest.com to the custom URL, and then you add pinterest.com to the URL retaining parent category. So essentially what this does is it dual categorizes, well, let me take that back. Well, it sort of does, for all intents and purposes, it does dual categorize it, but it doesn't dual categorize it as a custom category. It just basically retains that categorization from its parent. So in effect, like I said, you kind of negated the reason for creating the custom category. But like I said, I thought long and hard on this particular function, and if you use it correctly, it will actually make things a little bit cleaner. And let me explain what I mean by that. So before you would create this custom category, let's say Pinterest, as I said before, and you would allow it for staff. But if you didn't want anyone else to get access to it, then you would have to block that custom category again in another policy after that allow. So in this case, right, let's say you add Pinterest there again, and you add it to the parent category, right? And you already have a policy that blocks social networking, right? So you would create a policy that allows the custom category Pinterest for, say, staff, and then underneath that, you have a policy that blocks social networking for everyone else. So what will happen is that transaction will hit that first policy. It'll say, okay, this is allowed for users, staff, and the security group staff. And then the next time that request comes in from someone other than staff, it will look at that first policy, will say, well, it doesn't match. And then it'll go down to the next policy, right? And then that next policy will say, okay, so this URL is categorized as social networking, and we have a block for social networking, so now we're going to block it. So like I said, it's sort of a way of making cleaner policies without having to create a corresponding block to a corresponding allow. But you have to be really careful how you use this because, like as I said, it can make things a little bit confusing. So I would use them sparingly. I wouldn't use them for every single custom category I create because there's, like I said, there's usually a reason why you're creating a custom category. So you just need to be aware of that. Okay, so now we're going to look at some common mistakes, and I believe that Diane has this portion.
Okay. So Gans was talking about custom categories here. Why do you need custom categories at all? Well, if SSL inspection is in use, adding a rule to a no SSL inspection list can be appropriate. Or if authentication is in use, adding a site to a no authentication list can be appropriate. Or if Zscaler categorizes a site in one way, but the LEA sees things differently, for example, if Zscaler categorizes a site as a game, which the LEA is allowing, but the LEA thinks it's bad social networking, recategorizing it and putting it on a blacklist is appropriate. Now, on the other hand, if the site really is miscategorized and not just a judgment call, please open a ticket with MCNC to get this fixed. So those are the basic valid reasons to do custom categories. So how would you see how Zscaler has categorized a site? Well, this would be under that question mark in there, the help, where it has URL lookup. And we're using this example. If you wanted to look up poker.com, you could see that it's categorized as gambling. and you're blocking gambling. So in this case, there would be no need to have poker.com on a custom list. So it's a good idea to look up a site before you put it in a custom category, especially for a block. Okay, our next slide here indicates what not to do in terms of wildcards. If an URL starts with a dot, in other words, a period, anything before it is a wildcard. So if you have .ibm.com, that would match ftp.ibm.com, www.ibm.com, and just ibm.com. So you wouldn't really need 3 entries on a custom list because we use the dot. Next, an asterisk is not the same as a dot. An asterisk may be a wildcard on a PC or on a Unix regular expression, but it is not a wildcard to Zscaler and generally will not match anything in Zscaler. This is an example we created just for our demo, where we created kind of an anti-technology custom category called oddcat, and we decided to block Cisco and IBM, but in the Cisco entry, we used star.cisco.com or asterisk.cisco.com, and for IBM, we used the correct thing, which is the dot. And then we set up a block rule for oddcat, our anti-technology rule. And you can see from the logs here, first of all, the IBM block worked because it used the dot. But the Cisco block down below had no effect because we used the asterisk in the Cisco, which is ineffective. So this is based on the logs. We can see how the IBM rule was a match because of the dot, but the Cisco rule did not match because of the asterisk. Okay, this is from an actual LEA where we saw Microsoft in 5 different custom categories. Since .microsoft.com would include all the others, the dot at the beginning would be a wildcard. This could have been reduced to 1 entry because chances are the LEA didn't want to block Microsoft.com or be this granular on Microsoft.com. They could have just used .microsoft.com here, and it could have been reduced to 1 entry. Okay, another issue we sometimes see is inappropriate use of slashes at the end, mostly in that they're usually unnecessary. This is an example of how you might appropriately use slashes, because here we're just using Craigslist as an example, where there was one ad which was objectionable. And we're seeing that right at the first. We didn't want for folks to be able to see this ad, but we thought it was okay for folks to be able to see building materials. So we see the search /mat/ and the mat/ and anything after the mat would be a wildcard, which would be allowed. But for our last rule, Craigslist, anything else Craigslist would not be okay. So this was our policy that we wanted to implement. And we see here where we're applying our rules to our policy here. We don't want for people to see that one ad. We do want them to be able to search Craigslist materials and look at that category. But besides that, Craigslist is not to be used. Okay. This example shows an inappropriate use of slashes. Since these folks were probably okay with all of Microsoft, there would not be a need to enumerate chunks of Microsoft. In other words, there's no need for the slashes here. We probably could have, again, used just .microsoft.com. Okay, Gons briefly touched on custom categories and how when you recategorize a site, it removes the site from the original Zscaler category. Here we illustrate when it makes sense to recategorize a site and a possible gotcha in doing so. So we use our lookup here and we see that Zscaler categorizes a site, the North Carolina Education Lottery, as gambling. We want for our teachers to be able to buy lottery tickets, but not our students. And since we're blocking gambling generally, we need to recategorize the North Carolina Education Lottery. And so we do this here with our custom rule, um, let's see, called North Carolina Gambling or NC Gambling. And we put our education lottery in that rule. And here we see our finished category, NC Gambling, used in rule number 1. And we're going to allow staff to go to the North Carolina Education Lottery. And in our rule number 2, this is where we're blocking students from doing gambling. But when Zscaler goes through and is doing a test here, and a person is trying to go to NC Gambling, and it's a student, it looks at rule number 1 and sees, okay, there's no match for the student here. It looks at number 2, rule number 2, and normally this would match because we're blocking gambling. But since we've taken NC Education Lottery and moved it to the NC Gambling rule, rule number 2 no longer matches the student. And when Zscaler goes through all the rules, gets to the very bottom, has no match, it's an allow. Now we'd fix this problem for our students to keep them from buying lottery tickets with their lunch money by adding a rule number 3 to block students for NC Gambling, for an NC Gambling rule. Okay, one thing that should be noted is that if we have recategorized a site, Zscaler still shows its original category on the policy help lookup area. Okay, so when we suspect we might have custom category errors. How do we avoid this? We tend to see in custom categories sometimes hundreds of entries, which often do not make sense. So many entries that it's hard to figure out the original intent. Okay, let's see. Okay, this is an example of doing a lookup here. But okay, so this is an example where there are a bunch of sites that are in more than one category, and we see it's a bunch of safe browsing -cache or safe browsing dot for google.com. And here it's the Zscaler numbering, but we see custom category 7, custom category 40, we see 42, but there's a lot of safe browsing Google sites listed here in various custom categories. We actually could have compressed this into just 2 sites. We could have said safebrowsing.google.com, safebrowsing-cache.google.com, and used a dot before both of those and put them in one category and be done with it, and we wouldn't have had as much of a problem. So suppose we thought we had a custom category mess. How do we determine what all our custom categories are easily? Well, you can go into the custom category area and do a lookup of the URL in question. Or there's actually a hidden interface within Zscaler where you can look at all your custom categories. And we're going to show this in Chrome here. We logged into our Zscaler interface, and you can see where we went to admin.zscalerone.net ZSAPI v1 URL categories. Okay, these are all our custom categories. If we go down kind of towards the bottom, we've got a lot of our user-defined ones, where we've got Bing, we've got YouTube, Google videos, and so on. Those are really our custom categories at the bottom. So you're looking at this and probably thinking, well, this is still kind of a mess. I'm really not going to be able to sort through this. So what we have is a script that we've developed that you can use to parse out your custom categories. Okay, and I'm going to do a clear screen on my script. Okay. And our script is called parsecustom.sh. And if we try running parsecustom.sh with no parameters, it will give us a warning and tell us we're using it wrong. Okay? But we're going to run it correctly at this point. We've basically screen scraped all this mess that was here and put it in a file, and our file is called categories.txt. So we're going to say parsecustom.sh. We're going to run it against categories.txt. Doesn't take very long at all. And then at the end of the whole thing, it went in categories.txt.csv. We're going to more that file. And we see right off we got some problems at the beginning because we've got star.akamihd.net. We've actually got it 3 times. And as we saw, the star is meaningless to Zscaler. So we've got a problem we need to clean up there. Our analytics, about the first screen of entries, all has stars in them. Okay? So we should look at cleaning that up. There's some other issues in here. Let's see. How many Googles do we have in here? Yeah, we've got a bunch of Googles in here. So we could probably clean up our Googles. How many do we have? We got 42 Googles in here in various lists. Okay. How bad is the problem? How much duplication do we have? And let's see, sort. Okay, we've got brightcove.com listed 3 times in 3 different lists, various variations there. We could compress all our Brightcove entries. We've got 9 of them at least. We could compress into 1, okay, if we wanted to do this. You don't really have to be a Linux expert or a MacBook expert to do this, but most folks probably have a MacBook somewhere that they could run this script on, and we can provide you with the script. As far as actually looking at the data, it might be more user-friendly if you just took the CSV file that gets formed and then put it in a spreadsheet, if you're more of a spreadsheet person for that. Okay? So that is our little script there to parse out the custom categories. It is runs on MacBook or Linux, outputs to CSV, and you saw how we just took a screen scrape and did that. Okay. Another thing we're going to mention is about dual categorization and how dual categorization can sometimes be a problem. We see here where when we do our lookup, Zscaler categorizes the website with 2 different categories. Maxim.com is the website, and Zscaler considers it both entertainment and adult themes. So for blocking adult themes, Maxim.com would be blocked, and there wouldn't be a problem. But sometimes what we see is where folks enumerate allow rules prior to block rules, as we're showing here. So we have in rule number 1 an allow for entertainment. And we really limited it to one of our people, our user called Furry Ferret. And our rule number 1 is happening prior to rule number 2, in which we block adult themes. So basically, Zscaler would hit the allow rule for Maxim.com, where you're allowing entertainment, prior to the block rule for adult themes for Maxim.com. If you're not using any allow rules, you would never encounter this, but it's something to keep in mind. Zscaler compares traffic to each rule in the list, and if there's not a block or an allow in the comparisons, the traffic is generally allowed by default.
Okay, so this is an example of a common mistake that we see quite a bit. In this particular example, the site is trying to allow Twitter for staff, right? So they went ahead and they created a cloud application control policy for Twitter, right? Because it's usually easier to create a policy for an application without having to figure out all the URLs if you're using a cloud application control policy. So they kind of went about it the right way, but because if you look where their locations are shown, they are not doing SSL inspection. There is no way for this policy to work properly. Now, I will tell you there are some one-offs, right? Facebook is one. When you go to facebook.com, it loads an unencrypted page, right? But as soon as you put in your credentials and hit submit, it redirects to an encrypted page. So Twitter, which I verified this morning, when you go there, it is an encrypted page. So this allow rule would not work if you were blocking the category social networking, right? Because social networking would be blocked, would block Twitter, right? So without SSL inspection, cloud application control policies are not effective. Except, like I said, in the case of Facebook, which used to be my example until they broke it. So here's another common one that we see, similar to the last one, right? We're looking at trying to allow social networking, right? They created a policy. As you can see, we have a policy that's allowing social networking for staff, right? Once again, same scenario. They're not doing SSL inspection, right? Which in most cases, this probably wouldn't be a problem. If you weren't doing SSL inspection, this would work, right? But because they're using the default block to block social networking, this particular rule will not work. And let me explain. The default block gets evaluated prior to the URL policy. So there's no way to allow something that you've blocked previously. Right? Remember how we talked about order of operation, right? In this case, had they been doing SSL inspection on the location, the default block would have been ignored for that location, and then this rule would have worked. So like I said, sometimes thinking about the order of operation when you're creating policies is paramount, right? Because if you block something before an allow, it will never be seen by the allow. Okay, and that pretty much is the entire case of, as I always like to say, it's gateway, security, cloud application control, URL. That's sort of the order of evaluation when it comes to policies. So if something is blocked for a security threat, it cannot be allowed with a URL policy. We see that quite a bit as well. People get a security block and then they'll put in a URL policy trying to get it to work, and it won't work, and they'll get frustrated. And I always say, before you get frustrated, if you try something and it doesn't work, contact us. We will help you create the policy that's going to work for what it is that you're trying to do. Okay? Next slide.
Okay. Another common mistake we sometimes see when folks at site call us and say, hey, we're doing testing, things aren't going well, one of the first things we check is to see if the testing traffic is being reported in the logs during the day as road wire. If a device has a PAC file on it, we try and make that PAC file location aware. So it's doing a DNS test, it's doing a network test, and if those things are correct, then the traffic should be going through the GRE tunnel, and the traffic should not appear in the logs as road wire. If it is appearing as road wire, there can be a problem in the PAC file logic. You can exclude testing sites and that sort of thing in a PAC file, but people typically don't, because there are a lot of them to keep up with. But we do exclude testing sites at the router. So traffic goes through the firewall, hits the router. Okay? Typically, a PAC file is used off-site. So you've got your little person at the bottom. They're using TCP 9443. They have a PAC file on, might be a student at their home, and they would be hitting a Zen node in the cloud when they're at their house. But you don't want them to be using that PAC file when they're inside the LEA. You want the inside LEA traffic to be going across the GRE tunnel, so that any exclusions we have for testing, Renaissance, whatever, Classgate that we have in the router are going to be applied. Okay? In the router, this is how the exclusions typically look. You can see where we have a statement in the router to say if the traffic is port 80 or 443, we're going to send it to the Zen node. But If the traffic is destined for Certiport, Classcape, Britannica, Renaissance, and there are probably a few dozen in here actually in a typical router, then we're not going to send that traffic to the Zen nodes. So we've enumerated those networks, and actually we'll be using IP addresses on those. But if the destinations are any of those networks, we're not going to send them through Zscaler. So if you have a problem with the testing site and everything's configured properly, you're not using location unaware packed files on site, then the traffic is not going through Zscaler. And that's what we want. We don't want Zscaler to impede any of that testing traffic. Okay. There was a question on the Tech Director's alias early this year about using pack files to give teachers special privileges. So if you're not using authentication on site, how can you distinguish between a teacher and a student? Well, you can't do that easily, okay, unless you have your network laid out as such to have the teachers maybe on one network as far as VLANs, the students on another network as far as VLANs. Can you sort of elevate the teacher privileges by using pack files? Yes, we can do that. Pack files would be put on the teacher devices, and you would also have to put a certificate, one of the Zscaler certificates, on the teacher devices. And when you do that, the teachers then would be prompted for authentication. When this is done, the Zscaler rules can be tweaked to say if traffic equals road warrior, which pack file traffic is, and the user or group equals teacher, and that could be an Active Directory or in the Zscaler cloud where your users are set up, apply special rules to those folks. And here we're showing how the pack file logic can be somewhat different depending on the type of device in question. For example, a Chromebook does not do an IP network test. Everything for a Chromebook resolves to the loopback. So you can't really use the same pack file for a Chromebook as you would for a laptop because it's just different. Once in a while, we'll see where we have folks taking one of the stock pack files that Zscaler puts out there for everybody and trying to use those, or using a laptop pack file on an iPad. These things don't work well. So if you're going to try a new device type and contemplating how to do a pack file for it, please feel free to get in touch with us, and we'll make sure that the pack file that you're thinking about using is suitable for your device type.
Okay. So here are some other common mistakes that we see around authentication in SSL. First off, why is an application not working when authentication is enabled, right? And generally, these applications are not transactions that are being committed by a user through a web browser, right? It's some sort of application that is actually running on the host. And the ones that we usually see are usually like the Dropbox client or the Google Drive client or trying to think, the Twitter client. Basically any client that is running on the machine itself, right? This client is trying to connect to the internet, and it's on a location that is enabled for authentication. So therefore, since the client itself cannot authenticate against Zscaler, it causes that client connection to fail, right? So in the case of applications or clients or native apps, right, on a machine, if you're going to use those native apps, you are required to do authentication bypasses for those applications, unless, of course, that client is proxy aware. I will tell you that we've tested a few clients, and some of them work correctly, some of them don't. So it's almost a crapshoot as to whether or not they will work. But I can tell you that an authentication bypass generally will always work. It's just figuring out the different bits and pieces that need to be bypassed for authentication in order for that application to work, right? Now, also, there are some user agents that by default, Zscaler will bypass authentication for them. These user agents tend to be security related. The only one that I know of for sure that is not is wget. So if you're on a Linux box or you're running Well, now since Windows 10 will run Bash, I mean, you can run wget on Windows 10. So basically, that wget client is associated with a Linux operation, and by default, Zscaler will allow that to happen. I will tell you, if you use curl, because curl presents itself as a browser, that will not bypass authentication by default. Okay. Trying to think if there was any others. I also know that the yum user agent is not one of those that's automatically bypassed as well. You actually have to create off bypass policies for that. The SSL side, creating SSL bypasses, the reasons why you would do that. Lots of times there are certain applications, once again, that are intelligent enough to know that they're behind a proxy and don't like it, or the application does not understand or cannot utilize the Zscaler SSL certificate in order to be able to do SSL decryption. So that is a reason why you would need an SSL bypass, right? Once again, it's an application that's not overly intelligent. So it would require an SSL bypass. And then the final one in that is just this application doesn't work. No matter what we do, it just won't work. It's not happy, right? At that point, then that's when we have to look at a service bypass. That's when we're looking at GRE bypasses, right? So
some of the Apple stuff.
Yeah, some of the Apple stuff, and of course anything that we don't want going through Zscaler, which we, like Diane said, we have this big laundry list of applications that we bypass the GRE for, just because we don't want Zscaler in the way, right? So other issues around SSL inspection, mostly reasons why you want to do SSL inspection. A lot of people have decided not to do SSL inspection, and that's fine. I understand that actually having to deploy all those SSL certs is a pain, and if you don't have the infrastructure to be able to do that, it makes it even harder, right? But the advantages of doing SSL inspection is you actually get more uniformity across safe search, first off, right? If you're not doing SSL inspection, depending on the browser, sometimes safe search works correctly, sometimes it doesn't. We've also found that depending on the content that's coming across from the web to the client, right? Sometimes the antivirus scanners or the malware scanners aren't as effective. And then, just, sorry, lost my train of thought. We found that even across multiple search engines, right, they actually work a little bit differently. So SSL inspection is a good thing if you can do it. If you can't, then you have to live with that. But then what you need to do is to make sure that your default SSL policy is as stringent as it possibly can be. Okay.
Okay. And we have some commonly known issues across most content filters, not just Zscaler. Okay. First, we're showing how different search engines have different definitions of safe. Bing seems generally safer than Google, and here we show the search for butts. Bing considers butts unsafe, whereas Google considers butts safe to some extent. And we see here where we've got a pound safe equals strict up in our search bar, which indicates that safe search is on. So even though safe search is on, Google considers search for butts safe. Now, sometimes folks will ask us, well, maybe since butts are really offensive to our school, can I add a keyword search in Zscaler to say, I don't want people looking for butts? Yes, you can do that. But the problem is if you do a search on butter, butterfly, butternut, and so on, you'd also have a match for them. So it's kind of a can of worms if you get into the whole adding your custom keywords there. So we wouldn't advise it, but that does work in Zscaler. Okay. Zscaler also only filters ports 80 and 443. We saw that a little bit earlier, how the router is only routing those two ports to Zscaler for inspection. It doesn't do any odd port filtering. And traffic that you will see using odd ports might be viruses, proxy browsers like UltraSurf and Tor, or BitTorrent. So those are ports that Zscaler is not examining. Zscaler won't catch those kind of things. Many LEAs get copyright infringement nastygrams from the motion picture industry trolls about illegal movie downloads, which are typically using BitTorrent. Here's a small subset of movies which LEA users have downloaded recently. If you're getting the copyright infringement notification or having issues with proxies and viruses, locking down the firewall is the way to go because Zscaler does not look at these ports. And we see in the second column where BitTorrent is moving around and using different ports. And sometimes folks will ask us, well, we saw the traffic going out port 9663. It was BitTorrent. Let's just block 9663. Well, that wouldn't really work because that's how BitTorrent works, is it searches for open ports. So if we block 9663, the next day BitTorrent will be using 9664 or 43615 or about any other open port.
Okay. So we're going to look at some advanced features that I see turned on in other folks' UIs that are not effective only because of the way that we currently deliver the service. So the first feature I want to look at is this log internal IPs from XFS headers. Okay, like I said, I see this turned on in quite a few LEA's UIs, and I'm going to tell you why this does not work. It's not going to break anything. It doesn't have any ill effect if you turn this on, but it's not giving you any benefits either, right? So this particular function requires a proxy server, essentially, right? So there's a proxy server sitting on your network that is catching all of your traffic, right? And as that proxy server is passing that traffic along, it's injecting these XFS headers, which basically contain the IP address of the initial connection, which would be the internal IP address, right? I know that no one is running proxy servers in their network, so I know that this feature is not working the way people expect it to. Okay, the next feature I want to look at is the enforced surrogate IP authentication. Once again, another feature that seems like a good idea, right? So essentially what this feature does is that it looks at the IP address of the application that is connecting, right? And the application cannot do authentication, and you don't have an authentication bypass, but because it's coming from a known site, right? It says, let me just go ahead and pin this traffic to this IP address, and I'll just authenticate all this traffic because it's coming from a known location, right? Well, like I said, it sounds like a good idea, but because this particular function requires that the traffic be redirected from inside the NAT boundary, this particular function does not work because we redirect the traffic outside of the NAT boundary. And the last one I want to look at has to do with HTTP tunnel controls. Okay, like the first one definitely will work. Inspect tunnel to HTTP traffic. So basically what it's looking at, it's looking at those connects, right? If you ever look at an HTTP transaction, usually it's like a get for like getting a web page, or a post for like submitting data, like in a web form, or or a vote or something like that, right? That will definitely, it's looking for those connect statements, and that's what it's looking in order to trigger this inspection of this tunnel traffic, right? Because whenever it sees a connect as the method, it figures that there's some sort of connection that's being initiated here, so it sees that as tunnel traffic. The second function there, block tunneling on non-HTTP or HTTPS ports. As Diane mentioned earlier, when you look at the router proxy or the router proxy configuration, we are only sending 80 and 443 to Zscaler for inspection because that is how the service is defined. We are not sending non-80 or 443 ports or traffic to Zscaler, so this function would never work. Okay. So now let's talk about logging. Okay. Zscaler logs every single transaction. So it makes Zscaler logging a very powerful tool to be able to see what's going on, at least as far as your web traffic is concerned. Okay. Something that I see quite a bit is that people forget to click that log button and they start crafting filters and then they hit apply filter, and what ends up happening is they get this line chart, right? And they're like, oh, I forgot. And then they click the log button. Now all their filters disappear because it resets itself. So before you actually start crafting your filter policies, make sure that you click that log button so that it actually puts it into the log mode. So here's an example of a filter for trying to minimize the number of transaction entries that you're seeing in that display window. Because by default, I think you only get like 10,000 transactions.
100,000.
Is it 100,000?
Yeah.
Yeah.
There's still a lot to go through.
Yeah. So let's say we want to look for just Facebook transactions, right? So we go ahead and we click on add filter. And then in that, you'll see a bunch of selections there. The one we're going to choose is going to be cloud application, right? So we clicked on cloud application. Then you see that next window will basically appear. And it'll be cloud applications and then all. And if you click on that all, you'll see a list of all the different cloud applications. But if you know what you're looking for, you can actually start typing it in, and it will basically filter the results based on what you're typing. So we'll go ahead and we'll click on the Facebook filter, and then we'll go ahead and we'll apply this filter. At this point, we will see all the URLs or transactions that are associated with the application. So you're going to see not only just www.facebook.com, but you're going to see www.facebook.net. You're going to see the FBKN whatever. You're going to see all these different URLs. So why is this useful? Well, first of all, you've limited the number of results that show up in the end results, right? But let's say you were trying to figure out what URLs are associated with an application so that you could create a custom category. This would be a way of obtaining that information. Okay. So here's another example of a useful feature within the Zscaler filters. This particular one is the URL search. This was actually a very requested filter before it was added, I guess, 2 releases ago. And it is very powerful, right? But I've discovered in using this filter that sometimes it's better to use URLs or domains, depending on what it is you're trying to get at, right? So let's say you're trying to look at Facebook.com again, right? So if you were to put in there .facebook.com, right, you'd have to change exact match to contains, right? The reason why I say that is because if you use exact match, if it's not .facebook.com, it won't show up. And if you put www.facebook.com, that's all you're going to get. So you're going to want to do contains, so it shows you everything else, right, that may be associated with that, appended at least to that string that you put in there, right? But let's say all I wanted to do was look at facebook.com, right? So by clicking the domain button and leaving that as exact match, it will go out and it will look for just that root domain. So it'll find facebook.com, facebook.net. If there was a facebook.org, that would show up, right? So, and I will tell you that the differences between the URL search and the domain search is speed. The domain search is very, very quick. The URL search is actually slower. So unless you're actually looking for something within a URL string, where I usually use the URL for is when I'm looking for actually like some sort of search result, right? So I will actually put in like the search result that I'm looking for, that I'm trying to find to see how many people are actually looking for that particular search result, right? And then I would use contains as well on that particular search. Just know that using the domain is actually faster than using the URL search string. Here's another one where you could actually do the search by the destination IP. So if you know where the user is going, it's really easy to go in there and basically pull out all the transactions to that particular destination. Once again, this is a very fast search result. So now here we're going to look at actually putting together a bunch of different filters to actually get to a result. Okay, in this particular case, we're looking for the cloud application Pinterest. We've settled on a location, and we only want to see block requests. So why wouldn't I use a user instead of a location, or a security group instead of a location? Well, if you have an authentication bypass, that transaction will not be associated to that user. So you're going to miss those transactions, right? But if you know that user is at that location, you will see not only the transactions that are pinned to a user, but you'll see the transactions that are actually pinned to the location. And generally, those are all unauthenticated traffic is what gets pinned to the location, because it has to authenticate it to someone, right? And a location is a known source, so it's easy enough to pin that traffic to that location. So in this case, as I was saying, looking at Pinterest, I'm looking at that location where that teacher might be, and I'm looking for blocked transactions. It doesn't really help to look for allowed transactions unless you really know how the application is reacting, right? Generally, you're going to see a block if the user can't get to it. If you start to see, if you were actually pulling all the allowed transactions, it would probably be more than what you were trying to get at. So like I said, this is a way of just kind of distilling down that result to try to get to the problem. And this to me is generally how I start a troubleshooting session, right? Is I start to create these filters that will basically get me down to a point where I'll find what it is that I'm looking for. Now, let's say you did this, right? And you still have 10,000 results, right? Still kind of hard to look at, right? What you could do then is at that point is to export that file to a CSV and then drop that file into an Excel spreadsheet, and then use the Excel search functions to be able to get at the data that you're looking at. Okay, so just know that there is a lot of data inside the Zscaler logs, and this is probably the most effective way to get down to a point where the data is more manageable, because you can only get so many transactions back in each get, essentially, right? So if the data ends up being more than 100,000 events, you're not going to be able to get it all, right? So then you're going to have to start slicing it up into hours to try to figure out what it is you're looking for. But if you actually use these filters effectively, you will get down to a small set of results, which will make it easier to troubleshoot the issue that you're looking at. Okay, so this concludes our presentation for today. As I said, this is the MCNC Summer 2016 webinar series. This particular presentation was Zscaler tips, no tricks. Originally, this was supposed to be called tips and tricks, but I can tell you that there are no tricks in Zscaler. These results, for the most part, are predictable. You know, unless you have a bug, right? Bugs make things unpredictable. But for the most part, your results are predictable, so there are no tricks to Zscaler. But you could definitely get better at using Zscaler by utilizing some of these tips. And I know that there are a whole lot more, and we're always open, you know, to suggestions and feedback on these presentations, because we want these to be valuable to you. We don't do these presentations for ourselves. We work with Zscaler quite a bit. But I will tell you that sometimes without having the right questions, it's kind of hard to find the right answers. And I know that you all have lots of questions, so feel free to send those questions to us. We're more than happy to answer them. We're more than happy to work with you individually to help you, you know, get a better understanding of Zscaler. We try to do as many presentations as we can throughout the year, but I can tell you that, you know, we don't cover the full gambit, because we don't always know what the question is. But I can tell you that we can always find the answer. And if there aren't any questions, we'll go ahead and conclude this. As I said, the presentation and the recorded presentation and the slide deck will be available at www.mcnc.org/cne-webinars, and they'll be up there sometime this afternoon. As soon as we get a chance to make sure that we edit the recording, to make sure we cut out any dead space that we can pull out of it. Okay.